Hello, hello everyone. My name is Orestis Zekai. I am a software engineer. I work for Prodyna, which I want to thank for giving me the opportunity to present here today. Actually, this is not a presentation. This is more like a story. I know there are a lot of presentations today. Some of them are kind of technical, so I want to make this as easygoing as possible. So the title of the story is Helm, the hero in a Kubernetes deployment horror story. And our story starts with John. John is a senior software engineer who is working for k8s, which is a company which sells, well, couches. k8s has a software project whose main target is to boost sales and increase customer satisfaction, as most companies are trying to do. The stack they are using is the following. They have a React application for the frontend. Their backend is Flask Python. They are using Flask Python for the backend, and the whole thing is hosted on GCP on the Kubernetes engine. John, in his day-to-day work, he writes his code, he commits it and pushes it to a version control system, and there, after it's been peer-reviewed and merged to the master branch, a pipeline is triggered. The first stage of the pipeline is building some container images and pushing them to a container registry. This is required because, as we know, Kubernetes runs on containers. The next stage is some kind of quality check, which most companies also have. There the unit tests are run and some linter checks performs static code analysis on the code. And the last part, last stage, is the deployment to the Kubernetes cluster. Although Kubernetes is a really complex system that has endless possibilities, when it comes to deployments, I like to think about it simply. You describe the state you want to reach, and Kubernetes works its way there. Of course, this is a simplification, but in general, you describe the state you want to reach, and Kubernetes goes there. This is done with YAML files. In k8s, the setup of the microservice is the following. As we know, the basic building block in the Kubernetes cluster is the pod. But pods are ephemeral. They are not meant to run forever, and if they are killed, they cannot be brought back. And this is why the deployment is used. The deployment is a mechanism that manages the pods for you. You can define minimum replicas, you can define globes, and stuff like that. So we have a YAML file that describes the deployment. Next, we want to be able to route traffic to our pods. But as we know, when a pod is created, the IP is changed. This is why we need services. Services, you can think about them like a domain name service. They have a domain name that provides access to other services in the cluster and routes this traffic to deployment, the pods in the deployment. Last, we would like also to receive traffic from the public internet. This is why we need an ingress. An ingress is an object that, as I said, routes traffic from the public internet to our services, and from there it goes to our pods. So in this minimal example, we need at least 3 files: a deployment YAML, the service YAML, and the ingress YAML. So the way that we tell Kubernetes that I want my application to have this state is by using this command. kubectl apply. kubectl, kubectl, I'm not going into that debate now, but I'm going to call it kubectl. So the pipeline job that deploys the service looks like this. So first we authenticate to the cluster, and then we apply the 3 files one by one after another. So everything runs smoothly at k8s until one day a ticket is assigned to John. The ticket says that the sales of the couches needed to be synced every night with a third-party system that was handling the credit card payment transactions for them. It was obvious that the tool for this job was the cron job. John wrote the code that synced the two services, which was quite trivial, but when it came to the Kubernetes deployment, things were not so simple. Why? Because in order to create cron jobs, you need to create a file of the type cron job. So cron jobs, of course, do not accept traffic, so no need for a service or an ingress, and the deployment is not applicable here. So not only does John need to write the cron job of YAML, but instead he also has to go to the pipeline to this job and delete the files and change the way that this workload is installed. Because if it does not, these services do not exist, so the deployment would result in an error. While on this task, another one lands on his desk. This time, the team leader, Jim, noticed that some constants were hard-coded in the cluster. So he wanted them to be used as environment variables. This is pretty straightforward that we need a config map for this use case. And John again wrote the config map, but he had to go to this service and add the kubectl apply in this job as well. Days go by, and John is tackling these tasks with quite a success, but it's kind of tiring to change the pipeline every time that we need to add a new file in the Kubernetes configuration. Then Bill, the head of security, drops by his desk and says, "Listen, John, we have an upcoming security audit next week, and we need for our Kubernetes cluster to restrict the traffic from and to every workload. You need to create network policies in order to do this." The network policy is another YAML file type that describes for every workload the traffic that is allowed from it and to it, the egress and the egress respectively. As you can tell, this is a lot of repetitive work because John needs to create the network policy YAML file and also change the pipeline. But suddenly, a chat notification breaks the silence in John's office. The phone in the next office is ringing. People are running down the corridor up and down. We have an outage to the production environment. Clients cannot place their orders. Emails with importance set to high are sent all across the organization. The company is losing money. We need to fix this now. Time passes and no solution can be found. Working hours have passed long ago and everyone is looking for the problem. Finally, Mary, another senior software engineer in John's team, spots the error and applies a hotfix. It's almost 1 a.m. and the hotfix is applied and everything is over. Everyone can go home now. The next morning, everyone gets to work to find the following email. Dear k8s employees, first of all, I would like to thank everyone for the work you all put yesterday. It was critical that this issue was fixed. Of course, you will all be paid for your overtime. On the other hand, last night's incident cost the company a lot. Not only did we lose quite some revenue, but we got over 50 one-star reviews in our region. This is unacceptable. As a direct measure, the development team lead, Jim, has been removed from the company. His bad practices are what led us here, even though he was warned many times. You will all soon be informed for his replacement. Thanks, k8s CTO. When John read this, he was confused at first. He knew Jim had collisions with the CTO, but he never expected for him to be fired. But what happened next surprised John even more. The CTO entered his office. "Hi John, I guess you saw my email. We need to find a replacement for Jim." "Okay, I can refer one or two engineers from the team." "Actually, I was thinking that you would be the great replacement. You have been in this team for quite some time now, and you have been in the company for even longer. From now on, you are the new team lead." John was half shocked, half scared. He had big shoes to fill. "Are you sure? Don't you want to think this through?" "Yes, I am sure. You will start as the new team lead. Don't worry, if things go south, you will not be fired, we will find someone else, and you will be demoted to the old position. Your first task is to find a way to make Kubernetes deployments easier. Also, rolling back should be easier. What happened yesterday must not happen again." And then he just left. John was the new team lead, and his first and most critical task was to find a way for deployments and rollbacks to be easier in the Kubernetes cluster. After the CTO, Joe also left his office and he went to Mary's office. He wanted to share the news with her. He goes there and Mary was surprised. She was really happy for John's promotion, and to be honest, she would have promoted him as well. Then John, of course, was not sure. He still had doubts about himself. he thought he could not perform. And he says, I'm not sure, Mary. In my first day as team lead and I have a task, I don't even know how to start. How can I make deployments and rollbacks easier and smoother for the company? Well, have you heard of Helm? John paused for a moment to think. What is Helm? Maybe the solution to your first task. Got to go to a meeting, talk to you later, see ya. And then she just leaves. It was the second time in the same day that John was confused. What in the world is Helm? He goes back to his office, he opens his browser, opens his search engine, and types Helm. The official website comes up, clicks, and sees the following. Helm, the package manager for Kubernetes. This punchline created even more curiosity for John, which led him to scroll down, where he saw 4 bullets describing the benefits of Helm. The first bullet said manage complexity. Charts describe even the most complex app and provide a repeatable installation. Next was easy updates. Take the pain out of updates with in-place upgrades and custom hooks. Simple sharing, easy to version, share, and host. And the last was rollbacks. Charts, Helm promised an easy mechanism of doing rollbacks. These points did not make much sense to John, so he decided that some hands-on session would do the trick. So he clicks on the quick start, and after he installs Helm, he types his first command. Helm create my chart. This command created a folder named my chart with the following structure. There were 2 files, the chart.yaml, which contained some metadata like versioning and names, and the values.yaml. And there was a folder with called templates with 2 files inside, the deployment and the service.yaml. He opens the deployment.yaml and he sees references, some placeholders actually, that were references to the values file. He was quick to figure out that these placeholders were replaced by the values found in values.yaml. He goes to the value to this file and he changes the container image to some nginx version or whatever, and he wanted to see how he can deploy this. After searching, he found the command, which is quite simple. Helm install the name of the deployment and my chart. He sees some output on the terminal, and suddenly one pod was fired up with an nginx image in the test environment. Look, they even wished him happy helming. So it was quite clear that he did not have to apply the file one by one. This would make the pipelines much simpler. He even added a config map, he even added a network policy, he found the correct now command to upgrade the deployment, and just like that he was wished happy helming again, and the deployment was upgraded. And since they were simple YAML files, they could be easily versioned in some Git repository. Those Helm charts were looking quite promising. Another common issue they were facing in their organization was how they would define the differences between environments. For example, they needed different values in the test environment and different in the production. The test environment did not require so many resources. It would be cost inefficient. But Helm also had a solution for this. See, with Helm, specify files, YAML files, that will override the values in the values.yaml. So for every deployment in different environments, you can specify which file will override the values, the YAML with the new values. But what John was really curious about is how rollbacks would be handled. Because in the end, it was what got his previous team lead, Jim, getting fired. Turns out that Helm promised easy rollbacks and delivered easy rollbacks. You see, Helm comes with a database which tracks all the previous versions of every deployment. So rolling back to previous version is really simple. Helm rollback, you define which release you want, which workload, in other words, and the revision number. And just like that, you will have your system restored to the previous, more stable version. For John, that was enough. He knew he had found a tool that would ease deployments and rollbacks. So he created a ticket that in every service, every pipeline would change, Helm charts will be created, And yes, of course it would take a lot of time, but the benefits in the long term would be great. And just like that, John had succeeded in his first task. Of course, John's adventures did not stop here, but maybe this is for some other presentation. Thank you very much. Any questions, maybe? Anyone? Yes?
How does the Helm rollback differ from the Kubernetes one? Because Kubernetes offers kubectl rollout and do.
Which file are you going to revert?
All.
All. It does. I'm not sure about this. I have not tested, to be honest. I have only tested with Helm, but maybe you're right. Yeah, maybe I missed that. But it was one of the main benefits if you go to the Helm website. It's like number 4 with big letters, rollback, CG rollback. So yeah, this is why I. Thank you.